Or actually, there's a question for you. Is Kubernetes the land of Oz of rainbows and unicorns where nothing ever goes wrong?
So, no.
Let's get recording. Hello, sir.
Hey,
Oh, I have a bit of an echo. Let me check.
okay.
No, that seems fine. Maybe I was just too excited to see you and I got a bounce on the first one. We seem to be okay. How are you doing?
I'm doing, reasonably well. How about yourself?
Yeah, really, really well. I mean, except for the global pandemic and all, but look at this beard. Look at you. Like, you look amazing, man. I love it. I love it. You look so good. So off the top, I always like to remind everybody right off the start, this is an interview. We cannot get, keep that in mind so that you're not saying anything like naming specific individuals or bad mouthing anybody in a way that you wouldn't do publicly, right? Like, or don't badmouth people, but just say, this is a publicly facing conversation. Next, the second thing I always do, and I don't know if you've watched any of the other interviews yet, so I would understand if you're not prepared for this, but I need a YouTube thumbnail face. So, can you, like, I don't know, give me, I have this idea in my head that you're doing something like, or whatever, but, just do something 2 seconds for the camera. I will just rip the frame straight out of Zoom. So
here we are.
That's good. That's good. That'll do. Now, now we're starting the proper interview, and the place I always like to start is, tell me about your first memory or interaction with technology. Where did this start for you?
I think I was probably 3 years old. There's some game on the computer. We use DOS to access it. So we're doing kind of command line DOS stuff to get to the video game. And I don't remember a lot of deep details around what exactly that even looked like. Like, this would have been 94, 95.
Okay. Yeah.
That was the beginning, I guess.
That's it. And so you were like, right away, you were that. I mean, I think we all had that phase, or many of us did, where there was a video game going on, and that was really cool. Now, did that have ties to, it sounds like at 3 years old, you're watching somebody else do stuff. Is that your brother or father or?
Yeah, so my parents at the time were kind of doing IT consulting.
Okay.
They're actually doing IT consulting in Saudi Arabia at the time. Oh, and so there were a lot of, oil companies and companies like that had no idea what this whole technology or computing thing was. People didn't know what mouses were back then at some points in time.
Yeah.
But IT was, taking off everywhere. Yeah. And so they were doing a lot of kind of independent consulting over there.
Okay. That's actually really interesting. So at what point does this move for you? I guess, so you're 3 years old, we grow, and then you must have had exposures during school. Were there?
There were kind of some minimal exposures during school. One thing is that there were always books in my house around programming things.
Right.
So, you walk by a bookshelf and there's a very comprehensive guide to, C, let's say, right?
Yeah.
There were also, books around things like, 3D graphics, like, Blender, Maya, that kind of thing.
Yeah.
So just the household was always full of these materials to learn how to do those things.
Yeah.
If you read the book that teaches you, right?
Yeah.
I know in high school I did take a computer sciences course as well.
Yeah.
Visual Basic, awful language, but that was life back then.
And there was a bit there. I think about 1995, I guess if you're 3, so this is 2005, maybe Visual Basic was falling out of favor, but I did a lot of Visual Basic in 1999, 2000 for big companies, because it was built into Excel. And that's really important because so much of our information processing is based on Excel. Anyways, so your high school course is Visual Basic. You do a bit of that. is this where you start thinking that you could do this as a job, or was that just something that you grew up with right away?
So I kind of took a roundabout way to get to programming.
Yeah.
Not even really first, or wasn't the first career that I considered seriously. Yes. I guess even before I was doing the Visual Basic in high school as well. A couple of books are about kind of macro media flash player and making flash games.
Yes.
Again around the house. And at one point in time, I think my dad was like, if you build one of these flash games, they'll give you $50 kind of thing. Nice. And so basically just pushing me towards that to give it a shot, at least give it a fair try.
Yeah.
And so I remember I was probably grade 8, so that's 13 years old, I guess.
Yeah.
And there's some game that I'm building based on this book that I have, and it's basically like a pool billiards kind of thing. And I'm able to get everything working, and everything is playable and makes sense. But when you're 13 years old, grade 8, let's say, you don't actually know trigonometry. It's it's leaning on cosine and sine and things that are trivially obvious today. Yeah. I was like, I'm putting a bunch of equations in. I don't understand why it's working. Are we getting hung up on?
I mean, that's a metaphor for programming in general, isn't it? I don't know why this is working, but it is.
And in some ways, things maybe haven't changed so much.
Yeah.
But I remember kind of doing it. It worked, but it wasn't satisfying because I didn't fully understand it at the time. And so I remember coming to Visual Basic years later. I'm like, okay, I've programmed enough that I do kind of understand what programming looks like. This language feels dumb because in ActionScript I would just do this, but I can't do that anymore. I never got deep in the Flash player stuff after that either. But I think that was the whole beginning of things.
Yeah.
And it's funny that you mentioned the whole Excel tie into Visual Basic as well, actually.
Yeah.
Because one of the other kind of fascinations I had at the time was actually the stock market.
Right.
And so that came out of some bet that I had in grade 9 with some friends of mine. I found some online simulator where we could buy and sell pretend real companies on a pretend account and see who was doing better kind of thing. And so I had done well there. That seemed interesting. I started reading books. I was modeling out theories in those books with these awful spreadsheets, and nobody had even ever told me, you can throw Visual Basic stuff right into those spreadsheets. Else I totally would have done it and got into this whole thing much deeper, much sooner.
Yeah.
But I didn't, miss opportunity.
Sure. Well, I mean, life is a whole lot of missed opportunities. And, let me tell you, if I spent the whole interview talking about mine, it would be going on for a while. So this is good. So now we've made it to high school. You've done a bit of Visual Basic. What's next here? Do we move into university and start, or do you take a psychology or commerce or business or fine art? Where? It's grade 12. It's a day before I have to decide on which university, which program am I going to. And I basically applied to both a bunch of commerce programs as well as a bunch of engineering programs. Yeah.
And I don't really know what to do. So there's this idea where just toss a coin, and when it lands, you'll know what you feel you want to do, right?
Right.
So I'm okay, I'll toss a coin, and see what happens. But I toss the coin, and it shows heads, I guess. I'm well, heads says commerce. Am I excited? Am I disappointed? Am I kind of ambivalent?
Yeah.
I'm well, I'm ambivalent. I still don't know if I want to do commerce.
You reached over and flipped the coin.
No, I ended up doing commerce actually.
Oh wow!
And so I went off to U of T, studied commerce for a couple of years.
Yeah.
Started doing a kind of day trading thing, which again actually exposed me back to the whole programming world.
Yeah.
So I kept dipping my toes in that whole time as well. Because I guess when you're day trading, you obviously have this tons of data from the market coming in all the time.
Yes.
And so I think probably the most useful kind of thing that I built while I was doing the whole day trading thing is a lot of time some kind of news event will happen.
Yeah.
Maybe something awful, like a big oil spill off the Atlantic coast, right?
Yeah.
And if you can identify that something weird is going on in the world, in the market, in the first 3 minutes, I'm going to say, then you can make a lot of money very easily. But if you identify that something's going on in minute 8, minute 9, then it's already a crowded trade. Things are getting chaotic. Maybe you make money on it, maybe you don't. And so being able to kind of find stocks that are doing something weird within 2 minutes of them doing something weird is actually a very useful thing. And
So
so
could you write a trading AI? Would you
well,
execute
nothing so
trades, or would you
complex.
just be sitting in class and like you quickly tap your phone to say buy, sell? Like,
So I ended up getting a, I guess, something similar to like an internship kind of thing
yeah.
at a prop trading firm.
Okay.
And so basically, it was like a 9 to 4:30 kind of thing, where I'd show up, I'd trade on their account. There's like a profit kind of share agreement,
Yeah.
and then inside the actual inside a trading platform I had access to, I was using Thinkorswim at the time, which inside that had an embedded language called ThinkScript.
Okay.
Basically, write scripts to feed you information faster, allowing you to monitor hundreds of stocks instead of the 5 you can have on your screen.
Yeah.
And so it was basically like relatively simple logic around tracking the volume of that stock in the last 5 minutes versus the kind of expected volume of the stock over the last 5 minutes based on like historical data.
Right. Right.
That was sometimes useful for kind of catching those stocks when they were doing something more interesting than they would normally be doing.
Yeah. Sorry, I'm just muting my phone because I've had a couple of dings here and I want to make sure that I'm paying attention to everything here. But so this is really, really fascinating. So you were, and so how old or what age range is this? You're still in university,
Yeah, so it's like
part-time,
19, 20 years old.
19 or 20 years old, on an internship, writing effectively like, I don't know, stuff that I see as quant software, right? Like, or not quite high frequency trading algorithms, but like, I didn't know any of this about you, and this is really cool. So how was your performance using these methods? Were you crushing it? Were you doing okay?
So I guess these prop trading companies that you can basically go to have awful failure rates.
Yeah.
I think probably the entire time I was there for 15 months.
Yeah.
Probably in that 15 months, let's say they hired 200 people, which sounds about right. I think of those 200, probably 10 found any kind of success.
Okay.
And so almost everybody fails.
Okay. So you were one of the ones who did not have
Didn't
a high
succeed.
profit ratio for the sales or the buys and sells you made.
And so
Okay.
like, I think I made a lot more than most people did, but
Yeah.
not enough to be in that like 10 and 200 who actually, can continue on with it and have long-term success there.
Yeah. So now, so I have read a couple of stories about these things. And so my understanding of how they work is they have this thing where it's effectively a bullpen. You trade on their account, but it's using fake money. And if you make a lot of money or you do really well, they say, you're good enough to move into real money. So is that how it worked, or were you actually trading real money?
So that's how they do it for basically the first 2 weeks.
Okay.
So for 2 weeks, basically it'll be like a kind of fake money account. So you can not even learn what the market's doing or how the market works, but so you can basically get used to like actually executing trades.
Yeah.
And so like you might be in and out of a trade in 3 seconds or 5 seconds. And so just having the basically hotkeys understood and memorized and like intuitive, similar to like a video game even.
Right.
Basically means that, okay, figure out your hotkeys, figure out your kind of like muscle memory inside a kind of simulation environment, and then you start trading real money. But they start you very small. So it's like on day one of real money, you're trading 100 shares at a time.
Yeah.
On something that's like Wells Fargo at the time was probably around $40 a share.
Yeah.
And so if you make 2 cents a share on 100 shares, like that's $2. Nobody cares.
Yeah.
But obviously, if you can do it with 100 shares, you can do it with 1,000. You can do it with 10,000 in some cases.
Yeah.
And so basically, it scales very nicely to the point where, okay, if you can consistently make $20 a day with 100 shares, then there's no reason we can't just let you trade 10,000 shares now and turn that $20 a day into $2,000 a day, right?
Right.
That's the internal logic of prop firms, I guess.
Okay. And so, wow, what a fascinating, and you're still trading today, I imagine, but just not the day trading stuff. You just have.
I trade a bit, not nearly as actively, and it does take a lot of time.
Yeah.
Just to kind of continuously stay aware of that.
Yeah.
And to kind of be continuously aware on that side as well as upping my programming game, let's say.
Right. Okay. So
competing objectives.
Right. So trading has taken a back seat to programming because there's so much to learn in this space that you're just like, let's keep going. Now, so you've written these scripts for you've written Think Script, you've done this. How do you move into the next phase of your programming career? Because right now you're a trader writing programs. Where does what's the next step? Where do we go next?
So after a third year of university, I'm kind of like disenchanted with this whole, commerce thing. I'm like, do I really want to go work for like a hedge fund or something, or do that kind of thing? Or is it kind of like, I guess, not contributing to the world almost?
Mm-hmm.
I said, okay, I'm going to take a year off, maybe multiple years off, go on hiatus, not continue this degree that I don't know if I completely believe in anymore.
Yep.
And kind of while I try to figure out what do I want to do, I'm like, you know what? I've done a lot of programming at this point in time. I've done random things in Think Script. I've done Action Script. I've done Visual Basic. I was messing around with something called MQL4 for a bit at one point in time.
Okay. I haven't heard of that, but
It's a language for trading Forex stuff, and that's the language more geared towards actually placing orders and doing that whole thing.
Yeah.
So I've done a lot of programming stuff at that point.
Yeah.
And I kind of had like some ideas of like, okay, maybe I want to build like an app, let's say.
Yeah.
So if I want to build an app, what do I need to do? And so I basically take like a month and a half, do a lot of stuff on codeacademy.com at the time.
Yep.
Now we're talking 2012, 2013, I guess.
Right. Okay.
And after a month and a half, 2 months of Code Academy, haven't quite got to the point where I can build an app. But kind of some friends of my parents had some random website work they needed to do. And I was like, oh, yeah, I could handle that at this point.
Take a small side gig.
Exactly.
Okay.
They kind of started freelancing from there.
Okay. So your first paid job was for and this is interesting. How did you go from this first sort of paid side gig to, so were you going through like a recruiter, like a Robert Half technology, place me here for a few days and move on? Or
a lot of it was parental connections almost. And so they knew a couple of people who worked at agencies.
Right.
The agencies had, a lot of freelance work they were doing. They had a couple of friends that just needed ongoing work on their websites all the time.
Yeah.
So, that was a connection. It was basically stuff like that for
That's right. I had already forgotten that their IT consultant background would mean they've got their fingers in a lot of pies. They're like the octopi of like, oh, I've got a connection over here. Oh, do this. And so it would be, you were able to pick up those connections relatively easily. And you already had the friend trust factor. Oh no, it's my kid. Let's get, just do it. It's my kid. He needs money and I need him to not be a layabout. Like
You're not wrong. You're not wrong.
Not wrong. And how long does this last? And what kind of money are you making doing this? Is it good money or is it like beer money?
It's more than beer money, enough to like kind of live on, but it's definitely good money. Like even when I started like an entry level position, at my first, let's say, real professional place at Click, probably made more entry level there than I had been doing the
kind of. You had been making all before that. Okay, that's cool. Now, so your first, how long did you skip along doing these?
Like 3.5, 4 years.
3.5 years, maybe 4. So what kinds of things do you think that you picked up and learned at that time? What were some of the lessons that you're taking out of that?
So a lot of it's kind of project management, timelines, how to kind of just responsibly actually deliver things.
Yeah.
A lot of the time, the technological sophistication, it wasn't that deep a lot of the time. There's still PHP code being thrown around. They're still accessing databases, saving things, that kind of thing.
Yeah.
But it's not like it's not distributed, computing or anything crazy like that, right?
Right. Yeah. I would absolutely imagine that doing work for your parents' friends is a lot of WordPress sites and a lot of like just simple flat pages that aren't having, like you say, not distributed computing. They're
so like one of them was kind of an agency project for the kind of PGA Tour.
Okay.
And so they had basically hundreds of pro golfers who need quick websites that track some stats, use some plugins here and there. And so like that was one where it's like, okay, we need 30 websites over the next month and a half.
Right.
And here's some plugins that we've custom built in WordPress, so you can use and apply those. You might have to tweak them here and there to get them working.
Mm-hmm.
But like on the high complexity side, it could be stuff like that.
Yeah.
There's a lot of
that one sounds like a little fun. Like that one sounds kind of cool.
And like they were kind of deep into using the advanced custom fields plugin at that time as well. Yes. Which basically allows you to template things nicely in WordPress and reuse code a lot between projects.
Yeah.
And so it wasn't like ultra simple, but it still wasn't a deep and complex all the time either.
Right. Okay. So then we get to your first full-time professional job. That's Click here in Toronto. And how did that land for you? Like, let's just talk about the types of things you were doing and the things you were learning.
So that changed pretty dramatically over the three and a half years I was there. But in the beginning, I think the biggest change was that there was no more PHP. It was like kind of all JavaScript.
Yep.
And then just browser compatibility was cared about a lot more, in the kind of Click environment versus I think anywhere else in the world.
Yes.
That's just mostly Click is regulatory.
Yes.
Has a big kind of regulatory component in terms of building websites for pharma. So the exact way that claims are made is important.
Yeah.
And those claims have to look similar visually, even
across
if you're on
all browsers. Otherwise, it's real trouble. And so you're right. The focus is consistency everywhere with an iron fist, that it's got to be perfect wherever you look at it, or our clients can get in trouble. And that's a bigger problem than anything else. And so that's okay. So you started learning about that, and you were doing a lot of JavaScript. And okay, go on.
I think other big differences basically are it's a kind of much more mature kind of from a marketing standpoint. Yeah. And so, you're building the website, but you're also setting up, custom Google Analytics implementations, let's say.
Yes.
You're setting up emails, potentially those emails are going to a CRM system. You have to be aware of, different things there too. There's some level of integration between, your CRM systems and your websites, which in the WordPress world, some plugin is completely handling for you.
Yeah.
And so there was a lot more kind of, custom tooling where, previously I'd be like, cool, there's a plugin for that. Just use the plugin.
Use it. Right.
There are some things that Click was worse at the time at as well.
Okay.
So for instance, when I was doing all these golf websites, we had, certain, design patterns that the designers were familiar with, that, the programmers were familiar with. We'd use things like advanced custom fields to template across everything. Yeah. And there was a lot more code reuse between the hundreds of websites that were being thrown up.
Right.
Versus at Click, it was, in the beginning, at least, kind of the wild, wild west.
Right. And now, in defense of that, now, I find that, like, at least over here, so over here we're PGA, and it's one client all the way down and one project all the way down. So your code reuse within project is the same. Whereas if we're talking about over on the agency side, how many different clients were you working on? Or was it wild, wild west within a single client, or was it across many different logos?
So at the time, if you had basically the same client even, your code reuse inside that client would probably vary based on, the dev team working on it, and the design team working on it.
Yeah.
And I think the work that designers are doing to collaborate with developers wasn't necessarily, super close all the time.
Yeah.
And maybe it's even switching from the kind of consumer to healthcare professional side as well. Right. Or perhaps it's different designers in charge of those different things. And so eventually I kind of, led a attempted movement at Click to kind of, consolidate those things. And
you kind of picked up your pitchforks and you stormed the Bastille. Is that what happened? I love it.
But in the beginning, at least, I was like, okay, this there's a lot less consistency, I think, than there could be.
Yeah.
And I've seen ways of making consistency work.
Yeah.
And at some point in time, I'm like, okay, I'm fixing this. Let's try and see what fixing this looks like here.
Right. So you really, you led the charge, you took the bull by the horns, and you started introducing that. How did that go over? Was there a positive reception? Was it wildly successful? Or
I definitely wouldn't say wildly successful. And I think it was a big learning opportunity for me in terms of figuring out how to coordinate kind of organizational change.
Yeah.
When you have a lot of different teams, a lot of different stakeholders, different people have different kind of appetites for, risk and doing things that are, new.
Yep.
It was also kind of the first time that inside a company, especially, I was kind of branching out outside of the dev world because so at this point in time, I've been at Click maybe a year and a half, let's say.
Yeah.
I've developed a reputation on my team and with the people I work with for, reliability and I almost want to just say sanity. If I'm saying something, it's probably not crazy almost.
Yeah.
And enough people believe that they can be like, oh, well, Jordan's suggesting this. He probably has a plan. He probably has some idea for how this should work.
Yeah.
It's not a kind of harebrained scheme, I guess.
Yeah.
And so when I talk to, designers and people on the UX side, even business analysts and people, in different positions there as well, I'm like, okay, we need to template things. Here's how I suggest we do that. It was somewhat effective inside, my kind of department.
Yep.
But attempting to have those exact same conversations with people outside my department where I almost don't have the, I'm going to say political capital.
Right.
Right. Outside my department, at least.
Yeah.
People were kind of like, who are you? You're a developer trying to tell the designers how to work. You're a developer trying to tell project managers how to work. You're a developer trying to tell, any other role how to work, basically.
Yeah.
And that was definitely a big uphill battle.
Yeah. I can imagine that. I can imagine that. We're a couple of us hunchbacked programmers crawling out of their cave to say, how can we do things better? Go back. We're the cool people down here. Have you seen us? Look at me. I have fancy sunglasses and design. Anyways, because designers are so cool. I look around.
The one time that worked out well, though, actually, is there was a new office being opened in Philadelphia.
Yeah.
And so they had a kind of new creative team starting there.
Yeah.
And I was able to kind of begin talking to them about all these, plans about design systems and don't use Photoshop, use Sketch, and then have a shared, basically design component library for that specific brand as you're building everything.
Right.
And you know what? Start with the emails because they're simpler, and then do websites later on after emails are completely make sense and he was onboarded onto that.
Yeah.
I introduced basically a program called Abstract, which is basically allows you to version control design documents.
Okay.
And so with the Philadelphia team, which I got to early as our office
you
was
got them on board. You planted the earworm.
Yep. Got them kind of completely on board. They ended up mostly following, all the recommendations I laid out.
Yeah.
And I was talking to one of them not super recently, maybe 7 or 8 months ago. Yeah. It was like, man, I'm so glad we did all these things. Because even just having version control, I can make branches, I can do pull requests on the design files, meant that when this whole pandemic thing happened, it was still much easier to manage our team.
Right.
Versus having a bunch of design files flying back and forth, which is kind of status quo. So the changes were
really interesting.
But
so you've kept in touch with your friends from the old team and stuff too. So that's
a couple of them here and there.
Yeah. I mean, nobody's having weekly calls with their ex-coworkers, but it's nice to check in from time to time for sure. So that's interesting. And so we're probably at about the 2-year point, and you were at the agency for 3 years, maybe. Was it 3 years or 4?
3.5.
3.5.
So I guess the way I'd characterize it was the first year and a half in basically building things, launching things, trying to understand everything about how agencies work.
Yeah.
So I read a lot about programming and architecture during that kind of time.
Yeah.
Especially because I saw all these people around me who are smarter than me, better than me at different aspects of programming. I'm like, okay, how do I get on their level? So
Yeah.
sure, let's read clean code and clean architecture. Let's read books like 58 JavaScript design patterns.
Yeah.
Up until I know all the secrets.
Yeah.
And so for the first year and a half, it's just launch all the things all the time,
Right.
figure out how that works. Also figure out like other departments as well, though. So like I would read books on how do you design a website. I'd read books about account management from like a CS perspective, client services.
Yeah.
I'd read books about basically just what are all the different roles, what are they doing, what are their priorities, what do they care about, right?
Yeah. How much do you read? This is a lot of like reading and self-improvement and like professional reflection on your professional practice. Do you schedule like how much do you read?
So I was taking the TTC, public transportation back and forth at that point in time.
Okay.
So I was spending 50 minutes to get to work, 50 minutes back.
Okay.
I put things on basically the Kindle app. I think I spent almost $2,000 that year on just books on Kindle. But I probably read, I don't know, 30, 40 books that year.
Wow. Okay. And business, the nice thing about business books is, much of the time they're heavily ghost written and there's a lot of filler content. So you can kind of like tap the page, do a quick skim, and like you don't have to read every single word in a business book, but like
for sure.
you can still get a lot of the value out of it just by. So that's really interesting. Do you still maintain a practice of continually reading or continuous self-improvement in your professional life, or is that?
I think so I do, but I think it depends a lot on like what I'm currently working on at that time.
Yeah.
And so I guess the metric I always put for how hard is it to read a book is like typical programming book, you probably spend 35, 40 hours on.
Yeah.
Typical, non-programming, but also just like not hard science book, let's say probably 5 hours.
Okay.
And so if you look at it that way, then if I read, 50 books in a year, let's say, and it was all non-programming, that's about 250 hours of effort.
Right.
If I read 5 programming books, that's also 200 hours of effort, right?
Right.
Okay. So it's hard to kind of scale it that way.
Yeah.
Okay. So I'd say I'm probably keeping to that like 200 to 300 hours a year range.
Okay. Wow. Okay. That's that's pretty impressive. I've got to say it. In fact, which I know you mentioned a while ago that you had just gotten into your Google Analytics and things, and the moment we met, the time that we met, and the moment that you just blew my mind, where I said, this guy is a great developer, was around Google Analytics. And I don't know if you remember this, but this is seared into my memory like it's never going anywhere, because I had to come on board to, I think, one of your projects and do some Google Tag Manager work. And prior to all of this, we had been working in Google Tag Manager with a single JavaScript file where we just dropped in all of our listeners and it was just sort of, we stayed entirely outside of the GTM ecosystem. And you came along because I had to support this. There was no time for anybody else. And you just patiently sat down with me and said, this is how we do GTM. And you explained just the exact way that you're supposed to do Google Tag Manager. And it's like, wait a second, am I sitting with a guy who read the manual and did it the right way from the start? This guy is blowing my mind. And so around that Google Analytics stuff, that was really the key moment. It just snapped in place for me. The first time we met, I said, this guy is a fantastic developer. And I know when I first asked you to do this interview, you said, well, I don't know if I'm a great developer or not, but I'd be happy to help you out. And I really wanted to make sure that this was on record. You are a great developer. So
I think partially though, it was more like the whole 10x developer concept that was maybe railing slightly against.
Yeah.
And so we all heard the phrase, 10x developers, obviously.
Yes. Yes.
But I think a lot of are you a 10x developer here or there depends a lot of the context as well.
Yeah.
And so, for instance, if you look at like my early days, doing the whole trading thing, at that point, I am not a good developer at all. But I know very precisely what the problems are and very precisely what the solution looks like. And I know, if I do X, Y, Z, I can get good or bad results.
Right.
And so at that point in time, I don't necessarily have the talent to do anything complex, but I know what the simple thing that's going to work is.
Yeah.
And so I can take very little time, program something quick and simple, and get good results with it. Versus, I think the kind of prototypical 10x developer you think about is, I don't know, somebody who builds things very quickly or correctly all the time, or maybe writes unit tests and is responsible about their processes.
Right.
But I think it's a lot more context kind of driven than I think we typically give it credit for as well.
Right. Okay. I think I'm personally still trying to suss out what does a 10x developer really mean. I know that in a previous interview I was speaking with Arthur, who said that it's working to improve the people around you while never thinking that you're never being satisfied that you know everything. And then here's this one is, it's very context specific, that if you're 10x in one place, you might not be 10x in another. I think I've also started to realize, or I've started to theorize that actually the hiring guidebook for Amazon and Google and these big tech companies publish documents that say this is the bar you have to pass to work here. Mm-hmm. And I think that might also be a filter set for finding somebody who has the potential to be a 10x type engineer. And so I think there really is a confluence of all of these things that we're saying, but I still don't know that there's a super clear definition of what precisely makes somebody 10x, right? So
let's take it out of the developer context entirely then.
Okay,
right?
Yeah.
Say what makes somebody 10 times more just effective, let's say in terms of impact than anybody else, okay?
Yeah.
One thing that you could do is, and maybe even imagine you have a business and somebody else has a business.
Right.
And maybe your X that you're trying to calculate is the actual revenue. So how can you have 10 times more revenue doing the same thing as somebody else? So okay, let's say you have a web development business and somebody else's web development business. If you can handle 10 times the clients, well, you probably don't do that just by writing code faster. You probably build some kind of infrastructure, some framework around the whole thing. And so maybe that allows you to be a 10x business or a 10x company. I think looking at, okay, well, if you had an independent company, I think there's hints towards what would that mean to be 10x that apply to individual developers as well. And taking it beyond that 10x context, a friend of mine is working on a startup right now, and they're badly looking for a very experienced kind of veteran engineer. Yeah. And so I think if they find the right person, maybe their idea becomes a 100 million or 500 million idea. And if they can't find the right people, or they find the wrong person, and maybe the wrong person is experienced still, maybe they still have strong opinions, maybe they've done dev work, but they just don't quite mesh with that startup, maybe the whole thing ends up being worth zero. Right. So do we call that a 1000x developer then?
Amazing. Amazing.
Right or wrong person that basically sinks or swims the whole thing.
Yeah.
And similarly, flip that around a bit. Look at the Amazons or Facebooks of the world. What would a 1000x developer look like there? Well, it's probably somebody who has a clever idea that turns into the next S3.
Yes.
Now you have a product line based on that idea, and adding that idea makes them hundreds of millions a year. And so that's what 1000x looks like.
Right.
And so if I said, okay, well, how do you become a 10x or 100x or 1000x developer? it's probably figuring out what are the problems to solve,
Yeah.
especially what are the problems to solve that aren't obvious.
Yeah.
What does a solution for that problem look like? Especially a solution to a problem that you're not going to have competition around. So if nobody else is trying to solve something,
Right.
it's not just the marginal difference between what your solution is versus the next best thing. It's your solution versus nothing else exists.
Yeah.
And I think that's where basically impact actually comes from.
Right.
I mean,
and so this is like mind-blowing stuff, really, because we're saying it's not just that they're good, it's that they have that creative spark and that they can see things that the company can execute properly and maybe even be a first mover in this space. So they can execute it, they can move in the space, and they have the skill to actually either implement it or bring people along with them. So, okay, this is, man, see, this is why I love doing the interviews, because it's like, I get so much from talking to people who are a lot smarter than me.
and I guess
so, go
I
on.
think that translates nicely to when we were talking about Click. I said the first year and a half building, launching things, reading the books that tell me what everyone else is, doing or trying to do, and getting to know those other people's teams, what struggles they actually have on those teams. And the second year was basically trying to force the whole design systems thing to happen to, different levels of success.
Yeah.
And I'd say, the next year after that was basically a attempt to kind of template out emails so that, every developer who's had to work with, HTML emails hates the whole process. It's awful. You don't learn anything doing it. It drains your creativity. It takes too long. It's especially error prone if you have to care about, things like Outlook. And so, the next year basically was first figure out, okay, is there anything on the market that we can just buy to replace this whole thing?
Right.
The answer was those things exist, but they're all awful. And so the second part was like, okay, what potential solutions exist? And eventually we said, okay, well, can we parse the contents of a design file and create, finished, fully functional HTML emails from it, and then teach designers how to do that whole thing, which is where that whole version control thing came in as well.
Right.
So that ultimately, like, there isn't development work left there. It's handled by another team through a program fully automated.
Yeah.
So that's how I try to, apply the same 100x or 1000x idea that, I mentioned previously. I said, how do we introduce new products to solve that problem?
And how did that go? We probably shouldn't go too deeply into delivering competitive intelligence. I might have to bleep some of that even. But so suffice it to say that it worked at a proof of concept level, correct?
Yep. And definitely some brands used it more than others.
Yeah.
But
yeah. I mean, that's interesting. So now we're taught you, now you say you left partway through, and where did you go, and what was the thing that got you to start looking elsewhere? Because it sounds like you were pretty into this revolution, and then something external must have come along to say, oh no, that's even more cool. Or tell me how did that go?
So the year before, I'd basically been studying kind of machine learning and data science a bit. And so I'd gone through basically a couple of courses on like data camp, and maybe I'd sunk 120 hours into that. I'd sunk probably another 40 or 50 hours into like a Udemy course around machine learning.
Yeah.
So I guess my thesis there was that there's a lot of cool things you can do with just programming.
Yeah.
But there's a lot of cool things you can do with machine learning as well.
Yeah.
And especially, in the long run, even in the medium run, like let's say, next 5-10 years, machine learning is going to be able to do more and more and more and more.
Right.
And it's going to kind of scale in its capabilities a lot faster than any individual developer can get better, let's say.
Right.
And so I wanted to understand that machine learning thing deeper. I'd already spent probably 200 hours kind of, looking into that, getting an understanding what that field looks like.
Yep.
Then kind of a friend of a friend of mine was doing some basically consulting work with a kind of small startup in the kind of financial derivatives and machine learning space. And he was like, yo, you should talk to them. Or I think he even just mentioned, hey, does this job ad look like, reasonable at all? Or are they looking for the kind of unicorn that doesn't actually exist?
Yeah.
And so I looked at it and I'm like, okay, this is kind of a unicorn position.
Yeah.
Asking for way too much here.
Yeah.
Also, I happen to know all those things, so maybe I should.
But I am the unicorn. Yeah, it's a unicorn. You're not going to find anybody to do it except this guy. I love it. Okay. And the really exciting thing, I think, in that space. So there are a few things that happened in that whole sequence that I just heard. You saw where the market was going. You see where the market is still going, but you saw that you started studying early. You started studying right away. You got yourself to a point where you had all of the skills sitting there ready to go. And while you were thinking to yourself, what is the next logical step I can take in this space? The serendipity happened where there was somebody hiring exactly for the thing that you wanted to learn more about at that exact time. So you jumped into a full-time position with this machine learning startup?
So I've been even at Click in like last, I guess 6 months I was there.
Yeah.
I went to a kind of 80% schedule. So I was doing like Monday through Thursday versus Monday through Friday.
I see.
So that I would have more time to kind of work on some startup stuff on the side.
Yeah.
So I kind of continued that schedule, at my new company for the first, I guess, year I was there. And so it was close to full-time, but not quite full-time.
Okay.
And actually, so the reason I was like, you're not going to find anybody for this role was they kind of needed some blend of DevOps with Docker and Kubernetes, which I'd actually done before. They wanted somebody who could do kind of front-end development and websites, because basically they had like a bunch of like conference panels and things like that they wanted to kind of develop over the next year.
Yeah.
And then they also wanted somebody kind of familiar with Python and machine learning.
Yeah.
And I'm like, okay, well, your overlap between Python and NumPy and Pandas machine learning and React TypeScript is almost zero.
Yeah, that's right. They are a very separate Venn diagram set there. So, okay. And yeah, they wanted one person to do 3 jobs. That's typically 3 specialist positions. Okay.
For sure.
And you were doing this 80%. And what was going on with the startups? Are you still doing startup stuff, or has one of those blossomed, or?
So I was kind of moved from mostly developing to mostly kind of consulting on that side.
Okay.
So that's in a reasonably good place at this point now.
Okay.
I ended up going full-time at Riskfuel about a week ago, or 2 weeks ago, I guess.
Okay.
Officially, back to the regular kind of Monday through Friday schedule.
Yeah.
The second I did, I was like,
is Riskfuel the one that?
Yeah. So Riskfuel, as I guess the kind of quick description of that.
Yeah.
What they basically do is you'll have some kind of complex financial derivatives model.
Okay.
So like if you're familiar with stock options.
Yes.
Imagine options on futures, or options that have like just much deeper, more complex financial terms attached to them.
Yeah.
Usually because they're maybe an airline is trying to hedge something, let's say.
Right.
And so for a lot of these basically options price or derivative pricing models, they're basically doing kind of some deep simulation of potential market conditions to figure out what the actual value of that contract should be.
Right.
And so in a lot of cases, like that actual kind of the calculation to do that might take 5 or 10 or even 20 seconds to calculate the value of a single contract. So if you're a big bank and you have 100,000 of these, then now it takes 500,000 or 500,000 seconds to calculate everything, which is 6 days of CPU time.
Right.
And sure, you can spread that across a couple hundred CPUs to calculate everything in, say, a single night. But now if you imagine you're a derivatives trader and maybe Donald Trump says something crazy, or new news comes out in some way, the market starts moving a lot, you don't actually have real-time pricing information. You don't know what your portfolio is worth. You'll learn tomorrow morning when the batch job finishes, but you don't know right away. And so the thing that Riskfuel does is we'll take basically like a black box model that they're using on the client side, and we will figure out how to create, using our own internal models, hundreds of millions of synthetic inputs that represent different, things that the market could be doing. And based on those hundreds of millions of synthetic inputs, we'll run the calculations to figure out the value of that product would be, under all those different situations. So that creates like a trade database that we can use to then train a neural network on it. And the neural network, it turns out, because it's not doing some internal, kind of simulation, it's just doing a bunch of matrix multiplication. It turns out neural networks are often 1 million times faster. And so if their compute costs were 20 million a year or 50 million a year, which isn't even unrealistic for a lot of these companies, they can drop that by a factor of 1 million just by converting those models to neural networks.
Right. So, okay. So,
and so the big challenges of that obviously are to build this trade database. We have our own kind of data center set up.
Yeah.
Because it turns out running your own data center is actually a lot cheaper than cloud providers. Yeah. Assuming you're going to use all the CPU utilization all the time.
Yeah.
And so we have a couple of thousand CPUs distributed across our mini server farm at our data center that we use to price that that product 300 million times to create that trade database. And that's the kind of work I'm doing now.
And so, oh my God. So you can, and because it's a 1 million times faster or whatever, and so not only can they get this 6 days worth of data in seconds, but but the cost is down too. So I mean, there's the value of knowing
the value of your portfolio,
right away, so you can know if you buy more, sell more, whatever, and so by looking at the things that you're looking at one of these options, should I buy this option? And if you can calculate that in seconds, suddenly you're completely, so this is like, what was that thing? Think script. This is like think script times a bajillion. Like, it's incredible. And not only that, but you're selling this to people with money. Like I have heard that some banks have a little bit of money to spend on stuff. Don't hold me to that. Yeah, don't hold me to that. But I think some of these people have money. So that's a really, and so you're consulting on the side for these other businesses, but is that fading away because you're just going all in on this, or are you still?
I'm going relatively all in on Riskfuel. They have on Fridays now.
I can see why. I can see why.
And I guess the other thing I'm doing is I'm kind of phasing down. I guess the startup I was working with is a company called The Fitting Room.
Yeah.
And so basically their kind of big idea is essentially the idea of, we have neural networks again, of course. Yeah. There's a pattern here, I guess.
Yeah.
But, the idea there basically is if you can take a quick video of yourself on your cell phone, we're going to generate a 3D avatar that is exactly what you look like, including all your dimensions. It's like, let's say your waist is 33 inches.
Yeah.
The avatar respects that whole 33-inch waist kind of thing. And if we can then create custom clothing that exactly is tailored to fit you based on your measurements that we just got on this app, then everybody can get tailored clothing now of essentially higher quality.
Yeah.
One of the big problems with like buying clothing online right now is that you have something like a 50% return rate on most items.
Right.
If it's guaranteed to fit because we took a scan of you, we know your exact measurements, we can use slightly higher quality materials because we know we don't have those other costs or overhead.
Yeah.
Then you're more environmentally friendly because you don't need to throw away all the stuff that just happens to not fit anybody.
Yeah. Or the transit time back and forth, like all of that. Right.
And then we can actually show you, say things like heat maps being like, it's going to be this tight, around your bicep, let's say.
Yeah.
Or, whatever details you care about there, right?
Yeah.
And so people will be able to see exactly what it looks like before they buy it. They'll know, and like on their avatar as well, instead of just a kind of generic model.
Yeah.
That was kind of the core idea there.
Yeah.
So
go on. one of the things you were saying, so at Riskfuel, you were saying that you are hiring, and you mentioned some things about the Toronto market being difficult to hire in right now. Is that, are you?
Yeah, for sure.
Yeah.
I guess one of the interesting things, being on the other side of the table there as well,
Yeah.
is that at this point in time, we badly want people with a good engineering foundation.
Yeah.
But in an ideal world, they'd also have like a good foundation, like math and statistics.
Yeah.
And like it feels like those things should line up, but those things seem to actually very rarely line up.
Yeah.
Yes, because let's say you do an undergrad, math and statistics, like you'll understand that side. You'll understand the impact of all the different kind of simulation parameters that we might choose when we're figuring out what the product input looks like, how that affects our data set downstream, and then how that affects trading, the model on that data set.
Yeah.
So it's really nice for people to have that stats background, but we also need engineers who can basically build things in such a way that like we'll be able to reuse it across a wide range of client products,
right,
versus having it super hyper individualized for each individual thing.
Yeah.
And finding people who can do both of those things, fairly well has been more challenging than I thought it would be.
And you thought it would be, right. And so now that you're in the position you're in as somebody who is a hiring manager,
yep.
How do you design the hiring process to make sure that you're fine? Like, how do you go about just designing a process for finding people?
So in terms of like the interview and like the code interview itself?
Yeah, like are you loading up the How Big Tech Does Hiring website and going, okay, we're just going to copy this because if Google does it, it must be right? Or are you coming up with your own solutions that fit your needs a little more in a little more of a bespoke fashion?
So I think mimicking whatever Google does here is an awful idea because companies don't need what Google needs.
Yeah.
We don't need big data engineers in the same way that Google needs big data engineers.
Right.
The optimizations we need to do are very different than what Google needs to do.
Yeah.
And so for us to kind of copy their structure, I think would be just folly.
Yeah.
So how I basically set things up, and I don't know if this is too strong a hint. I don't think it is. I guess we'll see. But how to set things up basically is we have kind of one question where you're basically using the equivalent of like standard libraries to solve a problem.
Okay.
We have a target language that everyone needs to be able to know. Python in the case.
Yeah, you've got to know Python if you want to work in. And do you have I don't know how big Riskfuel is yet, so you probably don't. People. 12 people. So you also don't have the time for somebody who doesn't know Python to get up to speed on it, right? Like maybe if you were 100 engineers or 200 engineers, you could be, well, they're a good developer. We'll give them a couple of weeks to get their Python under their belt. So you're in this spot where it's high need for Python. And okay, sorry, I interrupted. Let me hear more.
I'd have to kind of think about that specific part because I don't know if that should scale based on the size of organization or not.
Okay.
But I'd have to think about that. What we're doing right now, at least, is basically a test where it's writing some fairly simple code using kind of the standard libraries that I'd expect anybody applying to know. And I want to see both how they design the code. So are the functions clean? Would the functions be testable? And in an interview setting, people never write testable code by default. So after they've written the not very testable code, I'll start asking questions about, okay, let's say you wanted to make this testable. How would you do that?
Right.
Let's say we need better performance. How would you do that?
Right.
Let's say we need, X, Y, Z. How would you do that with this code that you just wrote?
Yeah.
Get a feeling for how comfortable they are both writing the code initially, as well as kind of adapting to those concerns, even if they're not actually changing it.
Yeah. You know what I really like about that? That's because the nice thing about that from my perspective, what I'm hearing is you're in a very collaborative hiring space where you say, okay, write whatever you need for your first pass. And then now I'm going to introduce my pragmatic considerations where, okay, good, we know that you can solve the problem. Now let's talk about solving for this sub use case. And then there's another use case off of that. And it feels less gotcha, if you know what I mean, because one of the fears I think some people have going into programming interviews is they're going to give me an algo, I'm going to solve algorithm, they're going to give me an algo, I'm going to solve it wrong, I'm going to do n squared or something, and then they're going to kick me out for getting it wrong. and they're going to say you're a bad programmer and you should feel bad. I don't know that last one happens, but it's just, I can't prove it because I walk away from code interviews before I take them because I'm so scared. But that sounds like a really nice and collaborative process to me, where you're sort of bouncing ideas off of each other and just seeing, and at that same time, you really get this sense for them from a personality perspective as well, right? So you get to know if you like them a little, you get a sense for that. So that,
especially how well do they work with others?
Yeah.
And if I bring up a consideration, let's say, and this has never happened, but worst case scenario, like, oh, you're changing the requirements on me midway, like, you can't do that. Imagine that, for instance, right?
Yeah.
Well, real life involves changing requirements all the time.
Right.
So you kind of get a feel for how they kind of both tackle, do they understand how to kind of adapt to the situation, as well as how do they handle, very miniature, very reasonable curveballs.
Right.
That aren't the gotcha size curveballs.
Not gotcha. I mean, take this. We've discovered that we have to get to a better time complexity. Seems like a pretty, or we have to optimize performance. Seems like a perfectly reasonable thing. Or
and a lot of Riskfuel as well. Like, we'll have 300 million data points when you do some operation on 300 million data points.
And so should be fast. Yeah. So what are you working on now then, in terms of, from a technology perspective? What are the biggest problems you're trying to solve?
So I end up doing a lot of kind of software architecture consulting at my company. Yeah. So, we'll have some somewhat crazy idea for what we want to do. And the question ends up being, okay, well, how can we set up our systems so that we can do this kind of thing? And so, our default problem with everything all the time is we need to price 300 million points, and each of those is going to take 5 seconds to calculate. So how do we efficiently basically do 1.5 billion seconds of work across our 2000 CPU cluster? Yeah. I was doing some basically benchmarking yesterday, actually. It was like, okay, what are the recent kind of innovations we had? Was so when we're doing those like 300 million points, one of the kind of new constraints that I added myself 2 months ago to all of our kind of product schemas is we basically want them to be completely deterministic. Yeah. And so there's a lot of good reasons why you might want to just get a random number between 0 and 1 when you're kind of creating these market input parameters. But instead of doing all those kind of calls to math.random inside basically those individual classes, I instead want to basically generate the random vector outside of the whole thing, pass that vector of like 200 items in, and then use those values instead, so that we can basically say, okay, give me the most extreme case. Let's say we have zeros across the board. What does that object look like? Yeah. We have ones across the board. What does that object look like? Just so we can kind of test those edge cases, as well as just get like nicer distributions in various ways. Right. Okay. And so because we were doing that, we later on realized that, okay, it's actually useful when you're doing, the actual machine learning training stage to maybe you want to isolate, a bad point and get related points that are near it in that original 200, dimensional vector space instead of maybe your 400 dimensional trade space. But the cost of that basically is that as we're sending these messages from basically our kind of initial request generation step to these kind of 2,000 CPU pricers, or 2,000 Docker pods running on Kubernetes.
Yeah.
We're attaching this basically kind of 200 field item to each of those requests, which I think is probably increasing the kind of amount of throughput that we're sending through our cluster from like 200 megabytes a second to something like 600 megabytes a second. And I think we're basically using technology called Pulsar to handle our kind of message queue system.
Okay.
And I think we need to figure out basically either scaling Pulsar so that it can handle wider throughput, or perhaps this is a hardware problem and we need to just install better network switches,
right?
Or perhaps it's a compression problem, and for now we can figure out a better way to compress that data that we're sending, and then as we scale farther, do one of the other two things.
Right.
But that's one thing on my mind.
That's really, I mean, you've got, so, I mean, I'm catching up. I'm still trying to wrap my head around like the scope and scale of what you are doing from a computing perspective. So let me try and simplify this down for myself or the cheap seats in the back. You have a room somewhere with like 2,000 CPU cores. It might be, 500.
Like 70 machines, 80 machines, something
70
like that.
or 8. So you have a room full of 70 or 80 machines, and you send questions out to the machines, and they all just go, and they send back an answer. So it's like, and because of the amount of work you're doing in terms of, or the amount of data that you're starting to push through, you're going from, so you're sending 200 megs of data through to these 70 machines, but you've changed some stuff recently and now it's up to 600. And so you're having performance impacts by increasing the amount of data that you're dealing with 3x. And you're at the point where you have to start saying we need either faster networks or, maybe we just buy new machines to help and so like you're designing Skynet. Like this is incredible. Like this is like deep and like, wow.
So I think in the very short term, the problem will probably be kind of addressed by figuring out what we're currently do in terms of like compressing those messages before sending them.
Yeah.
And doing something smarter. It's like I'm pretty sure we're already doing things like gzip, which is the easy and obvious thing that every front-end developer probably knows at this point in time.
Yeah.
Maybe we could be doing things like protobuf, for instance.
Okay.
And so in the short run, I think basically just better compression works. In the long run, as we let's say we 10x our number of clients next year, right?
Sure.
Then now we probably need to maybe 3 or 4x the amount of hardware we have.
Right.
And again, we have that same kind of network bottleneck now where it's like, okay, we need to be able to send even more data through this cluster, even faster.
Yeah.
Another thing that keeps coming up is that I had never really, have you ever heard of Redis? It's like a kind of
Redis is the it's a caching solution, but it does a few other things, I'm told. I don't know what those other things are, but I'm told it does things.
So especially in like the last year, I'm learning to love the Redis here.
Okay.
Because it basically, so it's like an in-memory data store.
Okay.
And it's often used for caching on the website side. But it's so in basically all these kind of applications I'm talking about, you basically end up aligning your Kubernetes pods to your cores. And so generally when I'm pricing things, let's say, if I have 50 cores on a machine, I probably have 50 pricers running, one per core. And then, I allocate the work that way, basically, right?
Yeah.
But okay, so we've done that calculation. We have that value now. We want to sync everything to the same place again.
Yeah.
One thing that you could do is we basically had a storage worker set up at one point in time. So we basically have like message queues for everything. Yeah. You have your requester that says, price this, set of valuations or this valuation point. You have a pricer that's executing that, pricing work, and then that message would go to a storage worker, which is basically bundling sets of those things to save like Parquet files somewhere in, a data lake kind of structure. For some of what we do, the exact order of those points actually matters.
Okay.
And so if we can get those points to be in a certain order when we do the trading, we'll have more consistent statistical properties around some of our batch sizes that should lead to a smoother kind of training process for the machine learning downstream. The problem though is that, let's say you're running 1,600, pricing workers and 100 storage workers because they can't keep up with the throughput.
Okay, so let me stop for a second, because I mean, this really is a fire hose of information. So for my understanding, a pricing worker is the thing that tells the customer what their portfolio is worth. So that's the pricing job.
So each of these, so for us internally, this is to generate our trade database.
Okay.
And so each request basically represents a single kind of market situation that you could have. And we're going to basically use a pricing worker, which has a client model embedded, deeper inside of it.
Yeah.
And it's going to basically take that JSON that represents, the 200 fields that are at the market.
Yeah.
We pass it to that pricer that basically says, okay, here are the 4 numbers you care about or the 8 numbers that you care about in terms of the valuation. And then we want to basically save that in some structure somewhere.
Yeah.
And the reason we don't want to save it just to like a Postgres database or something is because at some point in time, we're going to want to pull down all 300 million of those rows.
Right.
And you probably just don't want to pull down a 300 million by, 600 column, basically just data object from something like Postgres.
Right.
And so those end up being these Parquet files that we're saving in something called Ceph, which is very similar to AWS S3.
Okay. Okay.
So because each of those pricers is basically pricing like an individual, ultimately something that's going to become a single row.
Yeah.
It doesn't have access to 1,000 or 10,000 of them to go save to a file somewhere. So it sends a message to basically the next step, and the next step is in charge of that actual bundling stage. And the problem that we have is if you have 1,600 of those pricer workers that you're running, those are going to go a lot faster than a single kind of storage worker can actually take those in, properly set them up, and actually save them somewhere. And so we scale up the storage worker as well. But at that point in time, you're not getting them in kind of consecutive order, which gives you good statistical properties downstream again.
Right.
And so the thing that Redis allows us to do is basically any time that you basically have multiple pods working on the same thing, sometimes having some kind of shared memory would be useful, right? In the same way that if you have a program, if you have to worry about, okay, well, we don't have memory here, fetch that from a database, versus just having it available, like it's easier to just have it available, right?
Yeah.
And so the thing that we are probably going to do with the storage workers in the near term is switch to those so that as they kind of receive all that data, first they save it to Redis, which is very fast because it's a completely in memory all the time.
Yep.
And then just basically query Redis to be like, do you have 10,000 consecutive yet? Do you have 10,000 consecutive yet? And when you hit some consecutive number, then it pulls it all down, saves it into basically those Parquet files again.
Yep.
And basically lets us dodge some long, complex, basically lengthy operations that we would normally have to do downstream, because we can basically use Redis to have the equivalent of like shared memory between those 100 storage workers that we're running.
Right. Okay. So
another kind of cool use case we have for that as well is let's say you were doing actual machine learning training, and I'm surprised this isn't everywhere because like we ran into this very quickly, but it's just an unsolved problem as far as I can tell. We have 8 GPUs on a single server. They're all trading different kind of variations in the model with different hyperparameters, right? So we have a terabyte of RAM on that machine. It's not a weak machine whatsoever.
Right.
Our data set's 500 gigabytes. And so status quo is you load from disk as you're kind of doing the training. And that loading from disk might end up being, in our cases at least, we're seeing 10 or 15% of our training time. Sometimes more depending on the situation, depending on file structures, file formats, that kind of thing. I think in the worst case, maybe it's 30 or 40%. And so if reading from disk is expensive, obviously the solution that, things do is why don't you just cache it in memory, right? And the problem obviously is, again, if you have a 500 gigabyte data set, we could cache that in memory if we train it on a single GPU. But if we're doing that on 8 separate Kubernetes pods, then now we would need 4 terabytes of memory. Not really feasible. And so the thing that you can do there is you basically have Redis running on that same server.
Right.
As you load things, you push it into Redis. Then as you need it, you retrieve it from Redis again. And now that Redis storage is basically like shared, basically just RAM across your 8 GPUs, across Kubernetes pods. And in theory, at least, that should be a lot more effective for basically any training task. And like, even if you look at the cloud, a lot of cloud machines have multiple GPUs, but like this just doesn't seem to be a standard pattern that I've seen so far.
Right.
So,
so you, like, are you the one physically plugging in like RTX 3090s into these machines in this room somewhere? Like, are you?
That room is in Montreal, and
okay,
I've never seen it.
You've never seen it? Yeah, I would think that. Tell me now. You've mentioned Kubernetes a few times. I think everybody who would watch an interview with a programmer about their career would probably have some. Actually, no. Why don't you tell me what Kubernetes is?
Okay, so Kubernetes is a solution for when you want to manage many jobs across many servers.
Yeah.
And so if you have a couple, actual servers yourself, or even if you have servers on the cloud, and you want to run, specific jobs or applications on those servers, Kubernetes is basically a layer that allows you to abstract a lot of the basically individual work around that.
Right.
It might almost be easier to think about, Docker and containerization first.
Right.
And so to quickly touch on, what that is, the idea behind the Docker container basically is that, in the old days of, 15 years ago, if you want to run an application online, if you want to have a server somewhere, somebody is going to, set that server up, whether it's by SSHing into it or, whatever. Yeah. They're going to be like, okay, I need Python on this computer, download Python. I need these drivers, download those drivers. I need whatever other kind of configuration on that server, download those things. Maybe there's like FFmpeg to do some kind of image processing. And then you start your application, it does server things, people connect to it, all is well. And maybe a year later, you have to make some kind of modification. You need a new library, there's a security update, you SSH onto the computer again, you make those changes, all is well, it keeps running. And then maybe you have a new server that you want to launch because you're scaling up now. Yeah. You're like, okay, what is everything we've ever installed on the first server so we can replicate that on the second server?
Yeah.
Maybe you do an okay job at getting the exact same environment. It's good enough, it still works. A couple more years go past. You add 3, 4, 5 more servers. Maybe you can't find that library that you downloaded years ago. You're like, well, this older version or this newer version is probably exactly the same.
Probably close.
APIs probably line up. So let's launch those as well. And so that's state of the world 15 years ago.
That's I think one of the best. Well, yeah, I mean, the best cases in favor of Docker that I have ever had laid out for me, because it just so clearly and concisely describes the pain of server management in the old style. And so like enter Docker, right? This is where we are, that we've got. Yeah.
So enter Docker in the idea of containerization. The idea of containerization and Docker is you're going to still describe what you're doing in that server. You're still going to write pip install ffmpeg if you need an image processing library, but you're going to describe all those things that you do to set up that server in a single Docker file. Yeah. That Docker file is going to basically start with some kind of base image that maybe represents just a clean Ubuntu operating system. Let's say you add the things that you want, all the commands that you're going to run inside that Docker file, setting up things like permissions, user groups, anything along those lines as well. And in the end, you get an image at the other side that has that exact same configuration. And now if you want to run that exact same configuration on 10 servers, you can just run that Docker image and you notice exactly the same.
That's right.
If you do need an update to some library, you add it to your Docker file, you create a new image, you update all those images on the old servers, you have a guarantee that basically all your servers are exactly the same in terms of the software configuration, at least.
Right. And because the storage of the files is separate to the actual machine itself, you can actually replace that Docker image and point to the same folder, and all of a sudden you've just updated the entire server without risking any of your valuable data. And so that's a really, yeah.
So you have ideas about, volumes is what you're referencing there now.
Yeah.
Which allows you to basically say, what is like my, I guess, server level concern in terms of setup, and then what's my application level concern or my data level concern.
Yeah.
You can kind of separate those in different ways that allow for some cleverness and get you basically just the guarantees that you want in software.
Right. Yeah.
And so Kubernetes is basically a program that allows you to kind of take those containers and describe, okay, I want 3 copies of my application, or 10 copies, or 50 copies, or replicas, I guess I should say.
Yeah.
And manage basically running those against your entire kind of server environment.
Right.
So if you have 50 servers and you want to run, these 20 images on, 20 of those servers, Kubernetes figures out provisioning and handling, make sure that, it's running on the correct number of servers, make sure if a server fails, the new one is, started up normally or naturally without you having to do anything.
Yeah.
So it kind of dramatically eases the DevOps process.
Yeah.
Obviously,
my understanding or the way I've seen it described is like Kubernetes, like Windows or Linux is an operating system for one computer, whereas Kubernetes is an operating system for N computers, right? Mm-hmm. And so that's my understanding of it. Sorry, you were about to keep going on something in that space.
I'd say basically, because at Riskfuel, again, we have let's say 80 computers, servers, and 2,000 CPUs across all of that. Kubernetes basically allows us to say things like allocate each of these containers exactly 1 CPU, and up to 8 gigabytes of RAM, and start this same basically application 1,500 times or 1,700 times.
Yeah.
Or start at 100 times, but scale up if CPU utilization is above 75%, let's say, using this auto scaling algorithm. And so when we want to manage all these things that we're running across that entire server set, Kubernetes makes it completely trivial.
Right.
I want to say completely trivial. Maybe that's a lie. There's a learning curve.
I've been sitting in this same interview as you. Nothing I have heard today is trivial, except maybe that PGA shit we were talking about earlier. So in terms of Kubernetes, was that already chosen when you came on board, or did you examine anything like Mesosphere or any of the other Docker Orchestrate? Have you done a comparison and contrast against the different, and why Kubernetes, if you have an answer?
It was already in place when I got there, which was, the big reason for me, at least.
Yeah.
I think one of the unique problems that I think Kubernetes is probably better at compared to those, although I haven't deeply kind of investigated it, is basically, so standard Kubernetes practice. You'll hear, DevOps people say things like, cattle, not pets, which is the idea that basically treat each of your servers as if it's like a random thing without an identity, and it can just kind of run anything. And we kind of break that convention a little, especially on the GPU side.
Okay.
So we have a couple of computers with our fancy GPUs that cost way too much money.
Yeah.
And we use those specifically for training. We have a couple of computers as well. They're set aside specifically for storage, which are very strategically located next to the training computers. Yeah. So that as we're saving, terabytes of data, whenever we want to move that terabyte of data to our training computer, that takes, minutes instead of hours.
Right.
But otherwise, and Kubernetes basically allows you to label all those, individual servers. So I can say, only run this job on a GPU computer.
Oh,
only
wonderful.
run this on a storage computer.
Yeah.
Run this on any of our kind of, data gen computers.
Yeah. And we don't we don't know that Mesosphere and Docker Orchestrate or any of the other solutions can't do that, but we know that Kubernetes does do that. And
Yeah.
so it's a really strong case for you to stick with the thing that you know that you need and you know how to do. Okay.
Yeah. There's other things built on top of Kubernetes that. So one interesting thing about learning Kubernetes deeply in the last year has been Kubernetes has a concept called a Kubernetes operator.
Yeah.
And once I saw this concept and like really saw it applied to a couple of things, I'm like, we should be doing this in regular software development for a million different problems. And so what a Kubernetes operator basically does is inside Kubernetes, you can define a custom resource. And so a custom resource is if you're familiar with Kafka or Pulsar or anything like that.
I'm not, but can you just...
So if you imagine any kind of like event queue system,
yep.
You probably have some kind of topic name. You probably have messages that you can pass on that topic.
Yeah.
And so when you're actually kind of managing the queue system itself, sometimes you want to add new topics to the list of topics that you can emit messages on. And that's going to be common to like any kind of publish subscribe system that you have.
Okay.
Right. And so the more complex stuff like Kafka or Pulsar that we're using, they have different rules and configurations around what you have to set as you're creating that topic. And while the exact details of all those things are not really important right now, the idea basically is that there is meaningful configuration every time you do that.
Yeah.
And so often in the old school way of doing things, you have some Kafka expert or Pulsar expert. He's going to set all those things up, manually by doing a bunch of command line commands on the server in the kind of, pre-Docker workflow that, we talked about.
Yeah.
What a Kubernetes operator does is it basically says, okay, when you have, so what we've done is we've created a Pulsar operator. And what that basically means is that we have a couple of very simple scripts that are going to read YAML files that are sent to Kubernetes.
Okay.
And so we'll define a YAML, schema that says whenever we have a topic, it's going to have these fields in this structure. And when we do, Kubernetes apply this file, then Kubernetes sees that file, takes it in, and says any operators that care about this basically topic with this or this Kubernetes resource can do whatever they need to based on this thing that we just received. But Kubernetes is very much aiming for statelessness a lot of time.
Yeah. And
so like if you have a defined configuration, it's going to try and transition your system to that configuration versus being declarative where it's like you're telling it to take these exact steps to get to that configuration. And so what a Kubernetes operator is going to basically do under the hood is if I basically apply this new resource definition, then the operator understands what series of steps it needs to take in order to create those things on Pulsar and configure it based on what you see in that YAML file.
Yeah.
If I now delete that basically resource on Kubernetes, the operator is going to see that delete command. It's going to be like, okay, the previous state of the system was this, the new state is that, and I have a basically set of steps I need to take in order to transition to get to like the new state. And so the idea of the operator basically is whenever you have an imperative system that requires taking a bunch of imperative steps to get from point A to point B, then there's always going to be a set of steps you can do. And a lot of the time that can be templated so that you create an operator that understands the imperative side of things so that whoever is managing it can now do it in a declarative way. And I guess to cleanly define that, declarative is like, I have a YAML file that describes what I want things to look like.
Yeah.
Apply that YAML file, the system figures out how to convert it to there.
Yeah.
Versus imperative, which is first I need to run, Pulsar admin namespaces, create namespace. Now I have to wait 10 seconds for that to, actually happen. And then I need to run Pulsar admin, create topic, topic name, -- persistent equals true, -- retention policy equals whatever, et cetera, to actually create that thing. The operator knows how to do that all by default, just taking the YAML file. And so what I was saying a moment ago when I started this whole, kind of tangent, I guess, is that whole operator concept where you take something that's currently imperative and make it declarative could have huge implications, outside of just the world of Kubernetes.
Okay.
So for instance, we use a program called Silverpop to manage your CRM campaigns.
Right.
Every single time you have a new CRM campaign for a new client, you have to basically establish all kinds of workflows around when XYZ event happens, send this email. When ABC event happens, send that email. These events are usually similar, at least, across the different campaigns.
Yeah.
But when you're using Silverpop, that's a very imperative process where to create that new workflow for a new client,
someone has to go in, go click, 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 save, click, 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 save, click, click, click. Yes.
And so if click, click, save is, version 0 of that whole process, version 1 of that process might be, imagine they had an API. Yeah. Now we have a bunch of API scripts and maybe we have bash scripts that create that whole thing, very imperatively still.
Yeah.
Still awful though, because, it needs to be a bit different this time. Now we're back to doing a bunch of manual steps in a very kind of imperative way. If you could create the equivalent of a Silverpop operator, similar to a Kubernetes operator, now you feed the Silverpop operator something like a YAML file, for instance, that says the entire system should look like this.
Yeah.
And then you basically have the actual operator there that understands how to create new things, delete things, otherwise just do state transitions, then what's currently literally weeks of work, but then requires extensive QA, which is hard to execute because everything's different enough that QA is not trivial. An operator-based system here that can take, that can basically translate that imperative layer to declarative would save a lot of time, let's say,
right,
a lot of money, simplify things, dramatically. And that kind of idea of translating the imperative to declarative, I think, well, I hope at least, it's probably going to be a big idea in programming, like I think next 4 or 5 years.
Okay.
The DevOps guys beat the application guys to it by a bit here, but I think the application guys have a couple of tricks to learn from that.
I certainly, from the Docker space and the Kubernetes space, I was just, again, mind blown when I first saw it. It was really because I do know that pain. I used to have to, in fact, on some servers, I still have to RDP into the machine and copy files for a launch process. And this one is, no, it's just you run it and it sets up the computer as a virtual machine, copies all the files in, and it's just beautiful. And then with the orchestration where, if one of your scale items goes down, it just it's a self-healing system. So people don't even get pagers. They don't get pages anymore. They just read the report on Monday morning that it was down for a bit, went back up. They talk to their application developer and say, there's something that's breaking on your system. And it's like, there's no more on call. There's no more pages. It's just you. There's still on call and there's still things still go wrong. I'm sure it's not this. Or actually, there's a question for you. Is Kubernetes the land of Oz of rainbows and unicorns where nothing ever goes wrong?
So, no. Such a land does not yet exist. And especially the way we're doing it, where we basically have our own data center versus having a cloud data center.
Right.
Things like something's weird going on with GPU 7. We need to reset the computer to see if GPU 7 will be seen again properly.
Yeah.
Kubernetes doesn't fix that, obviously, right?
Yeah.
I think though that a lot of the move to the cloud, you've basically seen a lot of cases where previously you had a DevOps team of 30 people, and now you need 4.
Right.
And I think that's a story that's been seen across a lot of companies in like the last 5 years. And I think there's a misattribution there though, where people say because you move to the cloud, you go from 30 to 4. And I think the actual truth is because you moved from essentially imperative processes,
right,
the steps you need to follow, to declarative processes where you say, this is what it should look like, make it happen. I think that's the actual cause of that drop.
Wow.
So if that's the cause, then even if you're running your own data center on Kubernetes, you're still getting the exact same benefits they got from going from, essentially old school to cloud.
Oh my gosh, you're proud. I don't know if you're right, but you talk a lot of sense, fella. Like that is a really interesting thought.
And if you look at the silver pop example that I was talking about earlier again,
yeah,
right now, sure. So even at a typical marketing agency,
yeah,
you have teams of CRM people managing CRM platforms in a very imperative way. And if you had a CRM platform that was declarative instead, then when you have a new project, you can copy a bunch of YAML files and be 85% done, versus needing to do a week-long process where you do a bunch of imperative steps, and then a QA person has to verify that you didn't mess up any single step anywhere along those lines.
right.
And QA is very expensive for that kind of thing as well as error prone.
Yeah.
If you moved, I think, from imperative to declarative systems there, I think you'd see the same kind of gains that you saw when DevOps went from basically typical on-premise logic to typical cloud logic, because I think imperative versus declarative is the actual advantage they gained.
Right.
And that's a kind of pattern you could replicate across a huge number of domains right now.
Right. And so what you've actually done is you've said that there is a CRM. I don't know if there are any CRM platforms out there that are fully scriptable like you're saying right now, but if there is one that's doing that, then they will be in a position to disrupt the CRM market. Or if there is somebody who is creating CRM programs for other people who is doing this stuff in a scripted way, as let's say they're a marketing agency doing CRM programs for third parties. The agency that can script their CRM program is going to be able to charge 10% of what an agency who's doing it manually could do.
So I think that's 90% of it. But so on the CRM platform side, I think there's 3 levels. Level 0 here is completely non-scriptable. There's no API, click buttons.
Yeah.
So it's level 0, status quo with at least some platforms.
Yep.
Level 1 would be, okay, they have an API. You can script against the API. You can't do everything through the API, or you can't accomplish everything through the API.
Right.
So somebody needs to click things still. And the third level is, okay, it is completely API driven. Anything that you can click on, you can do through the API. And that's a company that would have an advantage going forward, but that's not in itself sufficient. And so after that, it's not just can you script it, it's can you basically build the equivalent of that Kubernetes operator that allows you to say, here's my set of YAML files that say what I want it to look like, do the appropriate operations to get from point A to point B.
Yeah.
And as long as you can, if you can basically build that operator that allows you to go from any point A to any point B on that platform, that's what allows you to basically get that 90% savings.
Right.
If you can't yet get to the point where I can go from any A to any B by changing some configuration files, even without understanding the underlying platform, then you're not going to get that 90% savings, because some specialist needs to do the equivalent of SSHing onto some server and start running commands from their knowledge base versus the computer understanding how to make that transition.
Right. Okay.
And so if somebody wants to make $1 billion, figure out how to make some operators to manage platforms.
Yeah. And it really would be, because if you look at the market cap of people like Salesforce, and I think Silverpop is now owned by IBM, but if you look at the market cap of these CRM companies, they are massive. That's a big deal.
There's that 10x question again too.
There is that 10x question.
What is a 10x or 100x developer? Well, we just saw a bunch of DevOps teams go from 40 people to 4. So I guess they're all 10x developers now.
Yeah, that's right. That's right. And So the other thing that that I think was a little nugget that came up out of there was you're saying that actually by running your own data center, it's much cheaper than cloud for you. And you are still recognizing the savings in DevOps by using K8s or Kubernetes and orchestration and all of this stuff. So that's, I don't actually have a question around that. That was, did I hear that correctly, I guess, is my question.
We have close to 100 machines that we're running. And we're running, at close to 100% capacity most of the time in terms of, CPUs being used. That is, thousands of cores. If we were to replicate that exact same, load on something like AWS, we would basically be paying the cost of those machines in probably 5 or 6 months, maybe less. Versus just owning the hardware and being able to run those for years.
Right.
So the cost is dramatically lower, and we're a 12-person company, and so we have like one full-time DevOps guy, and then we have DevOps interns. And between the typically 2 people, they're managing those 100 machines, and it's fine. And sometimes our DevOps guy gets bored and wants to do programming stuff, and so he'll start writing Python codes, throw some stuff with Redis together. At one point in time, before I joined, he set up the foundation of our React TypeScript app. And so it's a tiny team managing a huge amount of hardware. And it's completely possible and gives time for experimentation, added innovation, etc.
Right. So that's so your answer is yes, that it is really, I mean, it's probably, you tell me to bleep off if I'm crossing a line here, but are you guys targeting an IPO? Are you because all of this has so much potential in my mind that you're just ready to print, I think.
So I think at this point in time, we're kind of mildly profitable. We're not making tons and tons of money, but we're still in the process of figuring out how to scale this nicely. Figure out what the kind of client situation that is needed, I guess. The big struggle that we typically have is basically a lot of people who would be our clients either don't think what we're doing is even possible.
Right.
So there's a big what you have to generate 300 billion points, let's say. Which, coming up, that would take 1.5 billion seconds. How do you even do that? That's impossible. Well, we have a pretty fancy Kubernetes setup with thousands of CPUs available to actually do that task. So even if you couldn't do it at your current company, we can do it because we know how now. Or they'll be like, oh, well, you're using, market data, but the markets change all the time. So second the market changes, it's not going to work.
That's right.
Well, actually, no, we generate synthetic data that approximates anything the market could possibly do within a specific domain, which is why we.
Sorry for giggling. That sounds amazing.
And then they're back to 300 million points. That sounds impossible. And so there's a lot of things that we have to do to convince clients that what we're offering could even be done.
Right.
And I think there's probably a natural progression where as people who've worked with our software at one bank, let's say, change jobs, go to another bank, and go back to kind of the old way, they'll be like, whoa, at the old company, I could get all this information in real time. Why do I have to wait till tomorrow at this new company? Guys, go talk to Riskfuel.
Go talk to Riskfuel. Right.
And so I think that should just naturally grow our market fairly quickly over the next couple of years.
I would think so. And once you nail down one big client, now they're not going to share that they're doing it because that's a competitive advantage for them. But if there's a way for, I don't know that there's even a way for you to share that you're doing it, but you could probably share something like this interview and say, or the sales guy would go, well, if you don't believe this can be done, go watch Jordan talk about how he does it. And your eyes will probably glaze over. Don't worry about it. You might not get all of it, but trust me, there's a lot of smart stuff that gets said. and he sounds confident. So
yeah, like my first project at Riskfuel basically was leveraging my front end chops.
yeah,
Where basically we wanted to throw up a website that takes basically an open source one of these models. So it uses something called QuantLib, which basically just has tons of financial models in Python.
yeah,
It does a kind of exotic product called a Bermudan swaption, which has some element of options. It has like an interest rate swap in there. I think it has a currency swap maybe too.
yeah,
And ignoring what all those mean, it can basically take 20 or 30 seconds to price a Bermudan swaption, depending on how long maturity on that trade is.
yeah,
So we basically built a website, which is a kind of like a calculator, but it lets you basically manipulate the like 200 input values with a couple sliders.
yeah,
And sometimes you have a single slider that changes, 7 inputs. And you can basically hit run, and you see, the Bermudan swap should be calculated using the old way on one side, and that might come back in 10 or 15 seconds. And then you see basically our neural network model returning a value on the other side, typically in 0.01 seconds.
Right.
And you can basically compare, okay, how accurate is it? Is it off by 0.1%? Is it off by 0.5%?
Yeah.
Can I manipulate this variable here to get it to be off by a larger margin?
Yeah.
Typically the answer is not really.
Yeah.
But yeah, so one of the first things I built was basically a way for individual, potential customers to see in action something that's similar in complexity to what they might be doing.
Right.
And to basically prove, okay, if we want to generate 10 of these, it's instant with our way, or close to instant at least.
Yeah.
And it's forever with, traditional methods.
Right. Yeah. So at some point, they're going to be hammering down your door. And maybe at the end of the day, you have 100 customers, but if we're talking about, but the customers are going to be Warren Buffett, Cathie Wood, and like, I don't know, one other mega investor, right? So, or,
like
James Pearson Morgan or whatever. I don't know who JP Morgan is, but like, I just wanted a third name. Yeah.
Big targets right now are basically big banks, hedge funds,
Yeah.
as well as the insurance industry. There's a bunch of kind of new insurance regulation in like the next 2 years, let's say, that's going to basically force them to mark their risk, I think, on a daily basis instead of a quarterly basis.
Oh, I see.
And I know, one group we've been talking to on the insurance side, when they basically have to do the calculations to calculate their risk for every single person they've insured, that process takes weeks for them in terms of compute.
Right. Yes. And
doing
it every day
doesn't scale.
Yeah. So you've got a solution there. What's and is that regulation Canadian or US?
I think it might be European, actually. I have to double check.
Yeah. So the size of your addressable market for just the insurance calculation is the size of insurance in Europe. Like it's got to be that's got to be more than $50. Like
you could probably get beer money for a couple of weeks there.
Yeah, right. Yeah. Speaking of beer money, right? Yeah, that's buy Germany money.
Yeah. I guess the interesting thing there too is like I just don't think there's any other vendors doing quite what we do.
Right.
And there's a lot of people who are like, that sounds impossible, so let's not even try.
Yeah. Man, your future is looking so bright right now. Like, man, for a commerce dropout, like
things work out nicely, I think.
Yeah, things are coming along okay, aren't they? How's everything else beyond that then? Like, so we've talked tech, you've got this mega bright future. How are you doing in the current pandemic state? Are you, so how are things?
Life is a lot more boring in terms of everything else than it was, say, 2 years ago.
Yeah.
I'm up in Canada right now. I don't know. Probably most of your viewers are as well.
Probably, yeah. I think we get like as many as 50 viewers per episode, so it's kind of a big deal.
But people watching this 2 years from now, who knows where they are,
That's
right?
right. That's right. When they say this is where Jordan started before he got
Um,
Warren Buffett.
yeah, I guess kind of crossing the fingers, hoping that this perpetual lockdown ends at some point in the near future.
Yeah.
Waiting for the world to open again.
Yeah. I got my first shot Thursday. I went into a local. I just crossed into the. I'm able to get it. I went into a local Costco and I said, "Oh, you've got the shots at the pharmacy here. How do I book one?" And he says, "Sit down over there. We'll give you one." And I like broke down in tears of joy. It was incredible. And then the next day, it hit me like a truck. I slept for 16 hours through the day, a headache, like kind of delirium around the pain. But it's clear now. And it's just such a good feeling to know that the first step is, the first step, and we're going to be able to end this thing. Like the end is in sight. And it's been tough. It's been tough to not be able to see people. It's been tough to not be able to go out. And you're
living through Zoom is life here.
Yeah. So, but that's part of why doing the interviews is so nice as well, because you actually do get this chance. Because normally you get these one-on-one conversations semi-regularly, like not 2 hours, tell me your whole life story, but like you get to talk about the things you're doing and the way you're feeling and what's going on. But like but we haven't had that. And so I think this is part of the reason that this is so appealing to me personally. And I don't know, I think we're probably in a good state to wrap up. And it was really nice to see you. I love this beard. You're looking so like good, man. Like, look at this,
thank you.
This chunk of beard, and you've just no, and like, it's so nice to hear that you've just, this Riskfuel thing, these guys are, so if somebody is a machine learning and statistics expert, and they wanted to get in touch with you because they saw what I see, they should reach out and try and get in on the ground floor of this thing that's about to explode but needs some help.
Yeah, they could basically send a message directly to my email at jw@riskfuel.com.
You're small enough that you get like your custom. Yeah, that's small.
They could also take a look at our website and basically apply for job openings through that.
Yeah.
Right now, we're basically looking for people who are kind of strong in terms of the engineering side, with an interest in statistics or machine learning. You don't have to know that already.
Yeah.
If somebody is the kind of person who likes reading scientific papers, let's say, because we end up doing a lot of research or reading of research at Riskfuel. And then they're a strong Python engineer. And we'd love to talk to them.
Yeah. Okay. That's great. I think. Is there anything else that you would want to sign off with, or anything? Is there anything that I didn't ask that you wanted to talk about? I think we touched on, because you had mentioned 3 things, and I think we got them. I was checking up on my phone. Is there anything else?
I think we rambled in the right directions today.
Yeah. Good. Okay. Well, Jordan, thank you so much. I've really enjoyed this, even though some of it, I'm not going to lie, I'm going to have to watch a second and third time to really understand what I just heard. But it was really cool and really enjoyable. And it's really nice to see you. And thank you so much for your time.
Thanks for having me.
Yeah. All right. Bye.
All right. Adios.